So in the sessions in the keynote so far, we've seen examples and use cases for how to best use a streaming platform with Kafka. This includes building business applications, business services that use, for example, maybe Kafka streams or KSQL to stream process events and data that are put into Kafka and to generate other Kafka topics. And also to then use, to move data that exists in external systems, either into Kafka or data that exists in Kafka and move it out into external systems. And that last part is really what I'm going to focus on today. So there are a couple of ways of doing that. I'm going to talk about the advantages of using Kafka Connect for that and explain how Kafka Connect works so that if you want to write a Kafka connector, that you can do that and understand how it works and do it well. So moving data into Kafka and out of Kafka, there are a couple ways of doing that. One approach is to use to write a producer application, and whether you're, anytime you want to move data or write data into Kafka, you can use the producer API to do that. And so a producer application that is moving data is responsible for pulling data from the external system and using the producer API and moving that data into Kafka. And on the consumer side, you can do this in a similar way with the consumer API. And you can write a consumer application that consumes one or more topics and takes that data and maps that into a data structure that you put into the external system. So this is pretty straightforward. But there are a lot of things that you have to do, and you end up having to do, except for the producing part and the consuming part, you still have to do all of the other work yourself. And so how do you handle restarts? So if you stop your application and start it again, where do you pick up? Especially in terms of the source system, where you're reading data, how do you know where to begin again? How do you parallelize all of this work so you just don't have a single process that's doing all this data movement? What metrics do I capture? How do I handle failures and retries? And using the producer and consumer APIs, they're relatively straightforward, but there's some best practices and some patterns that work really well. And if you don't know what those are, or if you don't follow those, sometimes you can get into situations where it's a lot more work. So as I said, this morning I'm going to talk about how Kafka Connect does these kinds of activities. And I'll start with the source side. And when you have data in an external system and you want to read that, Kafka Connect uses what it calls a source connector. And the source connector's responsibility is to talk to that external system, to map the data that it's reading from that external system into records. And then Kafka Connect takes over those records and does a couple of things. It runs them through transformations so that you can modify those records as they flow through. It uses connectors to converters to serialize those records into the format that then gets written via the producer into the Kafka framework. On the consumer side, the Kafka Connect framework, again, deserializes using converters. It runs through transformations again, and it hands those records off to what it calls a sync connector. And that sync connector is responsible for taking those records and mapping them into a data structure that it can write to the external system. And one of the advantages of Kafka Connect is that it does a lot of the work that I talked about earlier for you. The connector is not responsible for doing these things. Things like tracking offsets, tracking where it is, so that when it restarts in the right place. Being able to elastically scale the Kafka Connect worker cluster, to parallelize tasks, and distribute those tasks across all of the workers in the cluster. Metrics are built into Kafka Connect. Failure and retries, if anything goes wrong, Kafka Connect knows how to restart, and I'll actually go into a little bit of this in a minute. configuration management, there's a REST API, and so even though Kafka Connect is running, you could then deploy new connectors. You can deploy multiple connectors to the same worker cluster. And keeping track of what the configuration of those connectors is handled automatically by Kafka Connect. And Connect has a schema and a data type mechanism. Remember that the converters serialize and deserialize the information to Kafka. And there are actually multiple serializers. There's Avro, there's JSON, there's strings, there's protobuf, and you can write your own. You can actually, these are components that you can plug in. But connectors really shouldn't be aware of how the information is serialized, right? And so in order to do that, there's a schema and data type API, and I'll talk a little bit about that. One of the great things about Kafka Connect, though, is that there are a bunch of connectors that already exist. And if you can find them and install them, then all you have to do is configure it. You don't have to write any code. You configure a connector, you deploy it, and it runs, and it pulls data from an external system or it writes it to an external system. And so we at Confluent created Confluent Hub, which is a way to easily find connectors that people have written, whether they're companies or open source connectors. It's also possible to see more details about individual connectors, and so there are descriptions. There's features, there's references to documentation, if it's open source, references and links to the source code. And so Confluent Hub makes it really easy to sort of find a connector and get an idea whether it's going to work for your use case. One of the other things that Confluent Hub makes it really easy to do is install connectors. So on this installation tab, you can simply copy and paste copy that install command, and then using Confluent Platform, you can simply paste that into a terminal, and it will walk you through the automated installation of that connector into your installation. So if you can find a connector that works, by far the best thing is just to use that connector. Writing a connector, just like writing any kind of business application, can be challenging. There are a lot of steps that you have to follow. So if you don't have to do it, by all means use a connector. However, there are not connectors for every kind of system that you may want to talk to. And so the next step that I'd like to sort of walk everybody through is how does Kafka Connect work with connectors to do all of the things that we talked about earlier, all the failure, all the retries, the rebalancing. And so I'm going to switch perspectives a little bit. And Kafka Connect is a distributed system. It can form a cluster, and it's elastically scalable. We talked about the REST API. And so what happens when somebody uses the REST API and they submit a configuration, and all they want to do is this a valid connector configuration? Well, what Kafka Connect does is it instantiates the connector that's specified in the configuration, and it uses methods on the connector to determine whether it is a valid configuration, and returns that information to the user. So let's say that somebody is doing that and they've got a configuration that's valid and they want to submit that and start a connector. So what happens? They submit the connector configuration as part of their deployment request. And again, Kafka Connect will instantiate that connector, and it will it'll store that configuration in Kafka. And it'll call start on the connector. And this allows the connector basically to talk to the external system, maybe figure out how much work needs to be done based upon the configuration, and what it can do then is the next step is to ask Kafka Connect to ask the connector, okay, given this configuration, how many tasks do you want to run? And the connector actually does not do a whole lot of work. Instead, it defines a number of tasks that will get run, and the tasks actually do the work. And you can think of a task as a thread, or an independent. It's not a process. It runs within Connect, but you can think about it as a worker thread that's going to do a bunch of work. And so again, the connector may have to talk to the external system to figure out what work needs to be done, and it creates several task configurations. And those task configurations, Kafka Connect then writes into Kafka. And because the connector configuration and the task configurations are in Kafka, now any of the processes that are in the Connect cluster can read that information. And Kafka Connect will actually distribute those tasks across the cluster. And so the first step with a task is to instantiate it and to call start. And as part of the start command, here is your task configuration. And so go start establishing connections or any resources that you might need. And at that point, the task is going to start talking with the external system. It should have all the information it needs in order to connect. And once that's done, Connect will start to call poll. And it will just keep calling poll until the connector is stopped. And what poll does is, this is where the bulk of the work happens. It talks to the external system, it reads a bunch of data, it maps that into records, and it hands those off to Kafka Connect. Kafka Connect then writes those into the appropriate topics. And if we have more than one task, Kafka Connect will start the other tasks in the same way, distributing those tasks across all of the workers in the cluster. And so they're all independent, they're all working, they're all writing to maybe the same topics or maybe different topics. It does not depend. And I mentioned before that you can deploy multiple connectors, and so there may be other connectors that are running, and those connectors have their own tasks, and those tasks will be distributed across the worker cluster. What happens when one of the worker clusters goes away unexpectedly? Let's say it crashes. Well, there was a bunch of work that was being done on that process, and so when that process goes away, Connect, which had been managing where those tasks were being run, knows that those tasks are no longer running on a worker that's in the cluster. And so it will actually recover from failures by recreating the tasks, both for this connector that we're looking at, as well as the other connectors that are running in the cluster. And the connectors keep working, both for source connectors, which I'm showing here. Sync connectors operate very similarly. And at some point, someone is going to call the REST API, and they're going to say, I want to stop this connector. And at that point, all the tasks get stopped. They stop, they clean up what they're doing, and then the connector is stopped, and it cleans up any resources that it might have. Likewise, if other connectors are told to stop, then they are also cleaned up in the same way. So that basically is how Connect sort of manages and operates the connectors. So let's talk a little bit about what it takes to actually write a connector. I don't have a lot of code, but this is one of the cases where I wanted to show you what is the Java interface for a connector. And there are a few other methods I'm not showing here that are all optional for really advanced cases. But the first three methods are really just about the bootstrapping that I mentioned earlier. The config method returns what we call a config def, and that is actually used to describe the configuration and the allowed parameters and to validate. So all the connector has to do is build up and return this config def, and all the validation logic is already handled for them. The main three methods of a connector, are start, which I talked about earlier, where you're handed the configuration for a connector. The task configs method, which basically gives the connector the opportunity to say, okay, given this configuration, here are the set of tasks that I want to run, or that I want Connect to run for me. And stop, right? Stop just lets us clean things up. A source connector and a sync connector both extend this interface, but they don't add any methods. Okay, so connector is actually pretty straightforward, and I talked about those. Now, one of the things I mentioned that a connector doesn't really do anything. It doesn't do much other than sort of define what tasks need to be run. The tasks are actually what do the most work. And so here, source task and a sync task are different. They have different methods and different behaviors. There's a context that you're provided, and that's basically a hook to call back into the framework to ask to read various things and to get status and state and to make requests. But again, there's a start method, which I talked about earlier, the poll method for a source connector, and basically this method, the sole responsibility is to return a list of source records that Connect will then handle and write into Kafka. And so it's up to the it's up to the connector task to figure out how to do that mapping. And every time Connect calls this, the source connector should just return whatever source records are available. The connector, or the task, excuse me, can block. And so if there's no data actually available to be written, the task can simply just block and wait until there is. Or it can return, an empty list or a null list. It basically just means try again in a little bit, and Connect will do that. And the poll interval is configurable. And for systems that really push data, so maybe my task talks to an external database and is using an API, where that API will actually push information to the client. In that case, you may actually want to start up a separate thread so that you can handle those incoming requests from the source system. And then you simply put those onto a queue and have the main poll method just pull information from the queue. So that's a somewhat common pattern. Now, what is a source record? A source record is actually pretty simple. It's a topic and partition. Where do I want to write that into Kafka? There is a key and a value along with a schema for each of those. I don't have to have a key, but often if I have a key, then Kafka Connect will take care of putting that into a partitioning based upon the partitioner that is specified. There are headers. That's something that has been added to Kafka for a number of years now. And then a timestamp. If timestamp is important, I can add that. And then there's also something that we call a source partition and offset. Now, on a consumer, right, when you consume information from Kafka, there is an offset at which every message is stored within Kafka. And when the consumer starts, it knows, oh, if I'm going to read from this topic, I need this topic partition, I need to start at this offset. Right? And the consumer sort of keeps track of that, or you can tell the consumer how to do that. But we're talking to an external system, whether it's a database, a key value store, or some other system. And we have to know where we were last pulling the data from, right? And that's a function of the actual system. And so Kafka Connect for source connectors defines these source partition and offsets. And they're analogous to partitions and offsets in Kafka. But what actually a task defines as the partition is totally up to the task. And so, if you have any questions, you can either ask in one of the forums, or you can look at example connectors and see what they do. As part of, I mentioned earlier that these records are serialized using converters. And because connectors shouldn't have to worry about how they're serialized, that's configurable. And so in order to do that, it's often very useful for connectors to talk and to use a Kafka Connect schema and the record data structures and the APIs. And a schema is really a very simple abstraction. It can be mapped to other schema languages like Avro or Protobuf. And basically, there's a few pieces of metadata. Some additional sort of application-specific parameters, as well as a number of fields, right? And each field has a name, a schema, and an index, an order in which the field appears within the schema. You notice that schema is actually sort of self-referential. So you can define a field that uses a schema that is a struct, and that can have more fields, right? And so you can build complex data structures with this. Now let's switch to sync tasks. Sync tasks have a few more methods. There's the context, there's the start, the stop. Those are very similar, but there's 3 other methods. The first one is open. And a sync task, remember, a sync task is consuming, or a sync connector is, connect is consuming records from one or more topics and handing them to the connector. And so open basically allows the task to know, okay, here are your task partition assignments. So if you need to do anything, you need to create any resources or writers, or you need to talk to the external system and create tables, whatever you need to do, these are the topic partitions from Kafka that you are going to start getting records from. And if the task knows where to start beginning, and I'll talk about this just in a second, it can use that context object that I mentioned earlier to sort of tell Kafka Connect where to start consuming from those topics. The bulk, sort of the worker, the method that does the work for its sync task is called put. Very similar to the poll method, but the put method is called repeatedly with new sync records as soon as they're read from the consumers. And the size of the batch depends on a couple of things. It depends on records being available in those topic partitions, right? If they're not available and you're completely caught up, Connect won't actually call your put method because there's no work to do. Or if there are records, the size of the batch depends upon the consumer settings. And so these are typical consumer settings in terms of how big of a batch, how many messages or how many records to sort of put together as I'm pulling information out of Kafka. And then the put method's job is to either directly write that information, those records, to the external system, or to maybe put them into a buffer. Because maybe I want to batch a bunch of records together. I'm writing to a database and individual inserts take forever. And so maybe I want to put 100 or several hundred inserts all in one request. So you can do either one of those two things. Now, a sync record is very similar to a source record. In fact, most of the information is the same. The one thing that we have now, though, is we have an offset, right? The record is coming from Kafka. We actually have access to that offset position. But remember the source offset and the source partition information that source connectors use, they don't make sense in sync connectors because I'm reading from Kafka and I already have the topic partition and the offset. So sync records are a little bit more straightforward. And again, sync records are deserialized via converters. And so by using sync record connectors and task classes, don't have to actually worry about, how do I serialize this to a byte array so that it can actually be written into Kafka. The close method, so when you're consuming information from Kafka, you can have multiple consumers that form a consumer group and they all share responsibility of reading information from those topics. Connect is using the consumer API. And so there are times when either a worker fails or something goes wrong and the set of tasks, the set of topic partitions that I'm reading from changes, right? I've been reassigned new topic partitions or I've lost some assignments and I'm reading a different set. Close is a hook where Connect will call the task with the topic partitions that you're not going to get records for anymore. And this lets the task close any resources. If I've got records that I haven't yet written, I've buffered them, maybe I want to do that and send those off. Now, sync connectors actually have the ability to do exactly once processing. In order to do this, sync connectors have to do a little bit more work. And so what a sync task has to do is it actually has to track the offsets for the records that it has processed and actually written to the external system. It has to store those offsets probably in the external system so that if it stops and starts up, it can talk to the external system, read those offsets, and then tell Connect where to start. And by doing this, because you know what offsets you've written to the external system, right? You can hopefully do that atomically. As soon as a record has been written to that external system, you know it has been written, and you don't have to process that again. And because everything is totally ordered with respect to topic partitions, you simply have to keep track of the last offset that you've processed completely. And so one of the ways that sync tasks can be told how much Kafka Connect has actually processed is through this pre-commit method. You don't have to actually do anything. If you don't implement this, there's actually a default implementation. If you don't do anything with it, Kafka Connect will actually have the consumer store the offsets via the consumer based upon when you said that you were done with that all the records via the put method. But this allows you, for example, if your put method is just enqueuing some work to be done, but actually hasn't sent it to the external system, you probably want to override this method and say, as soon as I commit a batch of work, keep track of those offsets, and now I can tell Connect what offsets I've actually processed. Because part of the consumer offset functionality is you should only commit offsets for which you have actually fully processed those records. Not just that you've read them, but that you fully processed them. And this provides the hook for Connect to be able to do that. Okay, so that basically is a quick whirlwind tour of the methods and the interfaces that you have to implement and the methods you create in order to write source and sync connectors. They're relatively straightforward. The logic in them may not be, but they're relatively straightforward. And so what are some other things that you need to consider as you're implementing your source connector, source tasks, sync connector, sync task interfaces? Well, the first thing is that the only way to interact with the connector is via the configuration. Users should not be able to talk to the connector through some remote API and modify the behavior. Connect already provides that functionality as part of the configuration. And so it's important that you understand and that you sort of work within those bounds. Every Kafka topic partition is totally ordered. And so if you're a source connector, the number of topics and the number of partitions that you write to and how that data maps, that's a function of, that's something that you have to address. And so if you need something to be completely, totally ordered, and then you probably need to write to a single topic and a single partition. If order is not important, or if order is important, let's say you're pulling data from tables, and row changes in the table are order is important. I can write that to a different topic, but maybe I want to use a single partition. Or if I want to just have order for every row, maybe I partition by the primary key, but then now I can have multiple partitions in my topic. So all of this depends upon what system you're talking to. Scaling. The only way to scale a connector is really to create more tasks. For source connectors, again, it depends on what kind of system you're talking to. If there's only one thing that you can only have one client talking to the source to get the information, then maybe you only can have one source task. A sync connector, on the other hand, is completely a function of how many tasks that connector is consuming and pushing into the sync system. And so most sync connectors can handle generically an arbitrary number of tasks, and then they map that into how they're storing the information into the external system. Designing connectors for testability is pretty important. Unit tests and integration tests are obviously a common way to do this. We're trying to add some improvements to Kafka Connect to make it easier to create unit tests and integration tests that embed a zookeeper and embed a Kafka broker so that you can do a lot more functional testing within your builds. Continuous integration testing is obviously important. Know that you're not breaking anything as you make changes. And then, if you can use integration tests to run with an embedded zookeeper and broker, that's great, but that's not realistic. That's not how your connector is really going to be used. So you really want to have tests that test with a real Zookeeper cluster, a real Kafka cluster. And you probably want to at least understand how your connector performs and runs for long periods of times. Something to keep in mind is, how can my connector fail? I might lose my connection, and what do? Do I just stop and give up? Or do I maybe continually just retry and go into a loop trying to connect? One thing that a connector can do is if you don't want to have to manage the retries, you could throw a retriable exception, and that tells Kafka Connect, hey, what you asked me to do, I'm having trouble with, retry again in a little bit. And the framework is configurable, and you can, and then we'll call your task again with whatever it last tried to do. So think about how it can fail. Logging is important. Connectors are silent. They don't talk to the external system. They have metrics, which is great. But logs are an important way, especially as you're developing, to understand how Connect is using your connectors, when the methods are called, and then what your connector is doing in those methods. So a couple of tips here. One suggestion that I would have is not to log any record values as part of normal logging behavior. Maybe at trace level, but if you're going to use your connector in production, you don't want to be logging data and including your production data in logs, and so make sure that you're careful about that. I talked a little bit about config defs and how they can manage the configurations and validations. If you have any sensitive information, use password type, and that way Connect won't log that information, those values to the log either. I've seen a couple people write connectors that use the org.apache.kafka namespace. This is really reserved for sort of official things that are part of the Apache Kafka project, so just use your own package names. When you deploy a connector, Kafka has an isolation mechanism that was added in Apache Kafka 0.11. And this isolates jars, so if two connectors are using the same library but different jars, right, they're not stomping on each other. And Connect has something called a plugin path. And so here on the diagram, I've got 4 connectors that have been installed, 3 of them in one directory, one of them in a different directory. And the plugin path really should refer to those top level sort of parent directories. And then Connect knows how to look into a directory within there, and everything in that directory is isolated from everything in other directories. So keep that in mind. I talked about installing connectors, and this just shows a couple of ways, or it shows the install command and an example of how you can install a connector from Confluent Hub. And the nice thing about the installer is it sets the plugin path that I was just talking about. It sets it up correctly so that the connector can be found, and you can upgrade connectors this way as well. Now back to writing your own connector. If you want to publish your connector on Confluent Hub, we provided a packaging plugin for Maven that you can use, this is very simple. It adds some metadata that, all of the information that you saw displayed on Confluent Hub, all of that comes from, this process. And so the output of this is a single tar file that you can then submit to Confluent, and we'll put it onto Confluent Hub. There have been some recent changes to Confluent that you may be interested in. So one of the things in AK 1.1 was to add the ability to work with headers. And so part of the source records and sync records involve headers, and so if you want to make use of those, you can do that as of the Kafka Connect API in AK 1.1. In 2.0, recently we added a couple of features, error handling, to do more with retries and to handle bad data, especially for sync connectors, externalizing secrets out of the configuration files, and a way to actually plug and sort of extend the Connect REST API if you need to do anything special or add any more hooks. There are a number of improvements that we plan to make over the next few releases, and some of those are listed here. One of the things that I do want to point out is the 4th item, incremental cooperative rebalancing. So remember I talked about when a worker fails and the tasks get moved? We want to improve how that process starts to be less intrusive to the connectors that happen to not be affected. So this is going to be a really important and very nice improvement. It's not going to make AK 2.1, which is the release scheduled maybe next month sometime, but it'll be in the release following that. Okay, so I've talked about a lot of different things, but three takeaways that I'd like you to think about. One is you can write connectors. It's not that complicated. I actually showed you the interfaces and the bulk of the methods that you have to implement. The bulk of the work really is talking to the external system and mapping data in the external system to records. But most of the work Kafka Connect does for you. And so by doing that, connectors can sort of focus on, like I said, talking to the external system and doing that mapping. And then you magically get everything else for free. So here's some resources. If you find the presentation online after the conference, all of these are links and you'll be able to find those. But that's all I have. Thank you.
Thanks, Randall. As a reminder, please remember to rate your session. We really appreciate all of the feedback that you give us, and it helps us improve it. So please rate the session. And now we have time for some questions. Any questions from the audience?
Could you describe the externalized secrets a bit, how it works?
Yeah, so right now the externalized secrets is basically a plugin where you can, if you're using a secrets management system, you can, instead of a password in a configuration file, let's say, you can put a variable, and we have a specification for what that variable looks like. And then the externalized secrets provider will basically have an opportunity to read the secret at that location in the external system and provide the value, and that value is only passed directly to the task, to the connector and task. It is never stored anywhere, is never logged. And so the configuration that's stored in Kafka has this variable. It doesn't have the secret in that. And over time, we may provide additional implementations of that. I think that's the goal. But right now, it's something that you can pretty easily implement on your own using your own key management system.
How does Kafka Connect architecture compare to something like stream sets?
Yeah, so there are multiple ways of pulling data, out of external systems and into Kafka, or vice versa. This is something that's sort of native to Kafka, and there are techniques and patterns that Connect really works great for, and there are some cases like where if you are receiving requests, it's better to have a push-in mechanism where you're pushing the information directly into Kafka, and at that point it's probably better to write a producer application or to use another framework that is able to do that.
Randall. So for the source connector you mentioned, for the push style source system, we will have a separate thread to buffer the data, right? What happens if the task just happen to just lost, and will we just lost the data in the buffer then?
So yes, information will be lost in the buffer, but Connect keeps track of what offsets have been written. One of the things that I didn't show for the source connector, the source task, was there's a method that you can implement that basically will tell Connect, this is how far I've gotten. But you remember that for a source connector, right, you're pulling this information. If you're buffering it before you hand it to Connect, Connect hasn't even seen it. And so it will keep track of the source partitions and source offsets in every record. So when that record is written to Kafka, it sort of remembers that as the last place that it was. So it's a little bit confusing, but basically if you hand a record to Kafka Connect and Connect actually writes it to Kafka, it keeps track of that position. And then on task startup, it will hand that last position that it was back to the task and say, here's the starting point for that I last processed. start from there.
And one more over here.
Okay.
Hey, quick question on the Kafka connector. Exactly want semantics. I think you mentioned having an external file system manage the offsets, and there's a lookup process to see if the offset has been processed or not, right? So, is there a cost associated with that in the workflow?
So that typically happens when on the open and close methods of the sync task, which happen pretty rarely. It obviously happens upon first startup of the task, but then after that, it only happens if sort of a rebalance occurs. So it's pretty, it's very infrequent, but as long as it doesn't take like minutes to figure out, and I mean, you'll be fine.
Yeah. One more last question. I think we'll have it.
How does Connect distribute the work to the task?
Connect uses the same group management system that the consumers use to figure out what work has to be done. And part of that protocol, you can have what we call, what we refer to as a sub-protocol. And there's a Connect specific sub-protocol that the workers sort of exchange. There's sort of a leader that takes over, and it's responsible for assigning work. And that's one of the things that we're going to improve as part of the rebalance improvement.
Thank you.
Thank you, Randall.
All right, thanks. If anybody has any other questions, I'll stick around for a while, either here or out in the hall. So thank you.
Thanks, Randall.